So welcome also from my side to this webinar, Usage of AC500-eCo version 3 PLC with ABB Pluto safety controller in machinery applications. Today we have three presenters. It's myself, Johanne Veria. I'm the Global Application Manager for PLC and Automation in drive applications since 1st of January this year, but with ABB for quite a long time, since 2001, and located in Heidelberg in Germany. Now I give a word to Manuel.
Nice, welcome to all of you. Really cool to be here and seeing also the attendance. I am Manuel. I am based in Heidelberg here in Germany. I am the product owner for machine safety. So yeah, as mentioned, really glad to be here with you. I hand it over to Robbie.
Yes, thank you, Manuel, and glad to have you guys here listening to us. I'm Robbie Andersson, located in Sweden, Gothenburg. I'm the global technical support guy for developed machine safety solutions, and I've been working with machine safety since 2008. Thank you. Johanne.
Okay, thanks a lot. Then we'll start with the agenda. So we'll have a session of the overview of AC500-eCo PLC, a little bit to touch the topic where the functional safety is needed and why we see ABB Pluto safety controller as the right add-on here. Then we'll get a view on the ABB Pluto safety controller, and then we'll show you the integration of both controllers, AC500-eCo PLC and ABB Pluto safety controller in machinery applications. You'll see how they can be connected using CAN without any gateway. There will be a demonstration and then summary and questions and answers session, so you can put your questions in the chat or unmute yourself later on. So what do we have at the moment in our ABB automation portfolio of MODP is this figure, and today we'll focus on the left part of it where eco controllers are used with eco IO modules and also with the HMIs, CP600 ecos. These are usually simple machines, and for them we have a perfect fit with this offer. What you can already see here that the safety part is not included in that. And this is confirmed on the next slide. If you look at the platform, so all our AC500 CPUs can be extended with a safety, AC500S integrated safety. And the only part which is not included is our eCo PLC, eCo version 3 PLC. So today you may use some third-party safety controllers with it or some safety relays depending on application if it's still acceptable. And today I would like to convince you to use with the eCo ABB Pluto safety controller. And why, you'll hear further on. So first, a little bit an overview on the eCo. It's really a state-of-the-art controller with very nice feature set. I started here. There are different versions of it. Scalable, we just released high-performance version of it end of last year. So it's continuously updated, very cost efficient with onboard IOs, which you can see here, but still configurable with these slots here in the middle where you can put additional IOs or even communication options. It has all the needed state-of-the-art communications also up from OPC UA, MQTT to the cloud, HTTPS, FTPS, and so on. Encrypted communication and supported by Automation Builder, of course. We also have all kinds of building automation protocols or substation automation protocols, part of it, and also the Ethernet-based communication protocols for real-time control like Ethernet IP, EtherCAT, and recently also Profinet IO on board, which was launched last year. So we have Profinet IO device and IO controller as part of eCo CPUs. It's compatible with our S500 and S500-eCo IO modules and optimized with the state-of-the-art editors. So what is the only thing from our side which is missing here? So we have all the needed security requirements, communication protocols, and the question could be, yeah, what about functional safety? Yeah, the answer will come in the next slide, but before I come to this slide, I shall mention that we just launched also this CAN serial interface TA5146. CNW. This is the name of it, which can be ordered, and you see that it's it's an add-on component with a very good cost footprint, which you can just plug on one of 3 slots on the eCo CPU, and then have CAN communication directly as part of the eCo. And this module, which we just launched, also motivated us a lot to really highlight in this slide, which we adapted now with this CAN communication directly between the Pluto CPU and the eCo version 3 CPU. If you would put here this option board, which I just showed in the previous slide. With that, you would be able to map all the signals, safety signals, from the Pluto directly to the AC500-eCo CPU. Of course, it would work also with the AC500 CPU. It has on board CAN, but we are focusing here more on the eCo because here, of course, there is also an option of integrated functional safety, which is not available on the eCo CPU. And then you could trigger the STO, safe dock off, or any other safety functions. If you would have some, for example, some safety encoder connected to the machine access and then supervise safely the speed, then you can implement also much more sophisticated safety functions like safe stop 1, safe limited speed, and so on. So what we see here is this is completely new because before you would need a gateway here normally if you would like to map the states of the safety signals to the non-safety CPU, and then of course usually you would visualize them somewhere, for example, on the operator panel, HMI, or somewhere else. So typically in custom applications you want to map all safety signals, even if it's a standalone safety, to some central location so you see the states of all of them. And for that we have implemented a library, and there is an application example which is published in the chat, which explains step by step what you have to do. It's free of charge example you can download and directly use, and then read all the signal states which you can map to the Pluto. It will be also demonstrated in our video today. So it's very straightforward and very cost optimized in that way. And with this bundled solution, you can trigger STO on all the drives with the STO supported, including servo drives supporting STO safe dock off. The drives which don't support STO, for example, some servo drives we have today, then you have to use contactors to de-energize the drive side or motor side or both, depending on your application, to reach a safe state with that drive. Even though I shall mention that also our servo drives, of course, in the next steps will get also STO on board. In addition to that, and you'll hear that in the next slides, Pluto Safety Controller brings also very nice features like DIN link, where you can connect safety sensors in a ring and then connect it to just one safety input. So optimize on safety input number, and also multi-master principle to communicate between different safety controllers, and then even have some redundancy, which will be again covered. So this solution has also unique benefits. And from here, I give the word to Robbie to continue with the presentation of Pluto controller and later on with a demonstration. Please.
Super, thank you, Heini. Really good introduction. Okay, so Pluto programmable safety controller, great flexibility, powerful yet compact. And since you have the DIN link option, you also save inputs, to some extent cabling. The programming software is free of charge. In my opinion, one of the most easy safety PLCs on the market to program with ladder. And it's also possible to communicate with other sorts of field buses networks. The traditional voltage-free contacts like a key switch or an e-stop is possible to connect. OSSD devices such as Eden OSSD or LightGuard with the OSSD outputs, and of course the DIN link. It's a square wave 24-volt signal that you can use very effectively in different applications, especially in safety. And it's easy to modify, and it's flexible to just go online and monitor, or like in this webinar, ship the information bidirectionally between the non-safe eCo and our Pluto. No deep dive here, but here is the I/O configuration of a Pluto B20 version 2. It's fitted with 2 safe transistor outputs, Q2 and Q3, and then you also have 2 voltage-free contacts, safe relays, Q0 and Q1. As you can see, it's 24-volt power, and you also have the CAN bus and an identifier input for an ID fix. We'll get to that later. And if you need to scale it, if you have the demand for more inputs, just go up Pluto B46 V2. You can even mix them if you wish. You can have B20 and B46 or another type of Pluto on the network. And this one is just added extra relay outputs, Q4 and Q5. Yeah, and then we have the final one that I'm going to talk about. It's the Pluto D45. It's almost the same as the Pluto B46, but it also have safe analog inputs, up to 8 of them, 0 to 10 volts, 4 to 20 milliamps, fully functional safety, seal-3 PLE possibility. So yeah, that's the hardware. And we're talking about the bus. Up to 32 Pluto units can exchange data on the CAN bus, on the safety bus. And it's what we call a all-master system, which means that if one of the units goes down, the other units will continue to operate if possible, if they're independent of the one that stopped working for some reason. It also makes it very easy to split or scale or modify. And as you can see, it's quite compact, and the DIN link and also to a certain degree OSSD loops is possible. And in the B20, the theoretical maximum of safety sensors with using DIN link is 150. So that's quite a lot of power in this little box. Yeah, here is the programming interface that you can see in the picture to the left with the yellow block. These are ready-made, TÜV-approved safety function blocks. Comes with a complete description, easy to understand and integrate in the ladder logic. The program itself, Pluto Manager, is ladder, and it's provided free of charge. All you have to do is request a license key, which is also free of charge. Easy to maintain. I'm not going to deep dive into it, but hot swapping is to a certain degree possible. Here you can see the all master, and with that we mean that the left Pluto in the picture with the blue ID fix is fully possible to operate on its own if the right one goes down with its also ID fix number. It's a simple CAN bus cable, twisted pair, and then you terminate in the ends. And like I said earlier, it's up to 32 units possible on the same bus system. Status bus is one feature that we've implemented if you have the need to find out which sensor in the DIN link loop is currently on or off. So that one is good to know about. Finally, accessories. If you have doubts which ID fix to use, go for the black one. It's guaranteed unique and no confusion. And then we had other types like a yellow one where you can actually store the application in it if you have need for it. Could be good from a maintenance point of view. And like Haney earlier mentioned, it's also possible to connect absolute encoders to monitor speed or low speed or something like that. And we can also connect one of the CP600 panels directly to the programming port of the Pluto if you feel the need that you want to separate it for some reason or just have a checkpoint somewhere out in the factory. And finally, the programming is easily done by a USB cable to RS-232 interface. I guess it's the next slide then. And finally, how do you ensure safe torque off on a drive then? The most simple example is to simply utilize the 2 safe relay outputs of the Pluto B20, connect it directly and break the safe torque off in the drive. But what if you have a application with several drives? Yes, that we have an answer for, and you simply expand the safe output, the transistor or relay output with an expansion relay, in this case a BSR11. and then you can break the safe torque off of multiple different drives. Next one. We have some different expansion relays, like the BSR10, 3NO, 1NC, already mentioned, BSR11, 4NO, or the BSR23 with 4NO, 1NC. The advantage of the BSR1011 is that it's monitoring itself. So you have the possibility to just connect the safe output. But with the BSR23, you must connect a feedback signal to the Pluto and use a safe input to monitor its state. Depending on application or what suits your needs, it's just to select one of these. And in the EL sales organization, we have, in this case, the Sentry connection collection with a large number of electrical diagrams, how to connect the different Sentry safety relays in our range. For example, this one shows how to connect BSR23 to Pluto. It's very open, straightforward, and quick. You can download it and just show it to a customer, and they are usually more than happy. And now it's time for the movie, I think.
Hello and welcome to this presentation where we'll show you the AC500-eCo communicating with a Pluto programmable safety controller that is controlling a Sentry BSR11 for normally open safety relay, expansion relay as well, controlling the SDO of a ACS580 drive. As you can see, fully functional. The AC500-eCo PLC is fitted with an option board for a CAN interface. The CAN interface is connected to the Pluto safety controller using twisted pair leads. It's terminated in both ends. Inside on the option board there is a switch that you can use for the 120 ohm resistor, and here is a resistor fitted. So when you measure between CAN high and CAN low, obviously when power is switched off, you will have 60 ohms. The Pluto programmable safety controller is fitted with two safe transistor outputs, Q2 and Q3, and two voltage-free contacts, Q0 and Q1. Since this is a transistor output, I have used a Sentry safety relay BSR11 to expand it to 4 voltage-free contact outputs, and these break out the circuit of the SDO of the drive. The Pluto safety controller is fitted with an IDFix. This IDFix is used to identify the unit on the bus. The bus can be expanded with up to 32 Pluto units, and the AC500-eCo can communicate with each and every one of them. This one is necessary to have in a multi-Pluto application. The Pluto can also handle traditional voltage-free contact devices, such as an emergency stop with normally closed contact. OSSD devices like this Eden OSSD, or a light guard fitted with OSSD outputs, very popular on the market. And finally we have the ABB Eden DynLink. It's fitted with a dynamic signal unique for ABB. We activate the drive, and this time we activate the emergency stop of the Pluto programmable safety controller system. We see the drive stop. We reset the problem, and then we're good to go again. Oh, here we have Pluto Manager. Go to Preferences, find the driver for the programming cable, use P0, create a new project, add a new Pluto, in this case a Pluto B20 version 2, that is used in this application example. Connect the programming cable to the Pluto, copy the online IDFix number, and then paste it. Now you've married the Pluto and the IDFix together. Saving it. giving it a good name. We go to I/O options. Now we create a source for the dynamic signal, the dynamic sensor, Eden. It's an A-pulse square wave, 2575 duty cycle. Here's one channel of the emergency stop, and here's the other one. And the other one we're going to use the dynamic signal in. So it's an A-pulse, it's voltage-free contact. We doesn't expect it to invert, which it will do through any other DIN-link device, like such as Eden or. Here we can give the inputs that we use names, so we easily track them. So here is the emergency stop 1, channel 1, and then channel 2. Here I'm just entering a name for the source of the dynamic signal, but that's all you can do. Under the help menu, you find the Pluto hardware manual with good examples of how to connect devices to the Pluto. Here you can see the different dynamic signals that are available, A, B, and C, how to connect I inputs, and how to connect IQ IOs. Please note that we're combining an IQ dynamic signal with a static 24 volt. Like we can see in these examples of how to use dual channel systems, like the dual channel emergency stop 24 volt in one channel and a dynamic signal in the other. You can also find a block selection guide, and of course you should read the Pluto safety manual so you use the device correctly. And the selection guide gives you good examples on which block to use with which sort of input device. Let's look at the dual channel classic 2-channel dual channel emergency stops. The TC 2-channel, 1S, 2S, 1T, 2T could be a good selection of blocks. I'm going to go for the TC2T. Get a good description how the block works. Read it carefully. Pops in. We link the 2 channels of the emergency stop. Double click, drop down menu, find the one that you're looking for. We could have a test condition here, but I'm just simply going to remove it. We create new variables to store the status of the block, and this block monitors for 2-channel faults. That is when one channel goes without the other one also going low, and then the first one comes back, and then you have a 2-channel fault because the emergency stop is mechanically linked. We need to monitor that. Okay, so if the emergency stop 1 is okay, the block has evaluated the signals as okay, and simply we will map it to, in this quick example, to safe output. Comments are really nice to use. Will make it easier to follow and understand the purpose. So here, maybe you forgot to give it a name or just hard-coded it to this output, then you can go here to variables and enter the name. And it's updated in the code. Good description comment. The BSR 11 Sentry Safety Relay. use as an expansion relay. Changing it to a baud rate that works with the AC500-eCo, 500 kilobits in this case. You have to give a password when you download, that's to prevent tampering of the safety application. It'll be unique, nice, and be careful with it. Oh, go online. You can see the status. You can see the status of the signals, and then you can go to the PLC code to monitor what happens. Here I simulate a 2-channel fault. The first one goes and the other one stays, and then you had a TC fault. Now I reset it by pressing the stop, breaking both channels. And here is the final program I created with a reset 2T and then Adam DIN in. I also simulate the external device monitoring on the test on the reset 2T block. For example, the feedback from contactors. Let's have a look at the AC500-eCo environment. So here we have added the CAN bus interface with the option board. We set the parameters and the baud rate to 500 in this application example. And then we go to the CAN Open Manager, add it, and then we set it this, nothing special. We have no guarding, we have no sync, we have no time, disable everything. Finally, we add the library, which enables us to decode the traffic. It's non-safe communication. The data ends up in a global variable Pluto-com array. PC program adds the necessary Pluto-com and then read from Pluto and write from Pluto. Here we go online. You can see the different statuses. And here we can see the driver doing its job. RX counter is counting up. I'm showing it in binary now. And then we go to the different blocks that are available from Pluto and to Pluto if you want to send communication. Here's the driver. And here you can see Pluto present, Pluto 0 is on the bus. And globally, you can monitor. We can see global 0 have some data. That's the 2 inputs from the merge stop, the Eden DIN. When I press D stop, you can see them fall. The safe output goes away, and there I reset it. And there we go. Thank you for watching.
This is the final slide before we come to the Q&A session. So what we showed is, basically these 3 products connected together seamlessly. You've seen in the demonstration, it's our eCo PLC with the HMI potentially connected to it. We've seen the Pluto safety controller, and then we've seen the drive with the STO. And this complete solution, it goes up to performance level E, the highest one in the machine unique, so we can talk directly with the CAN, with the eCo, and as you've heard, you can read with this connection also the signals from application example, which you can read. It's about 20 pages, step by step, straightforward, and you have an exemplary project in Automation Builder. That some other supplier would come through the safety corner and try to take more also the control part. So it's all one ABB solution with a DIN link support, and would be glad to support you. And that's what I would like to show here on this slide. So you have at least 2 contact persons. One is the Manuel as a product owner of ABB Pluto safety controller. We are located in Heidelberg, close to each other, and then myself for ABB PLC with Pluto safety controller, and all these questions of integration we are ready to handle. And of course, depending on country to country, you may have different setups of your sales teams, but through us you have strong support here. And I think Manuel, probably you would like also to say a few words from your side.
Thank you, Jenny. I think that cooperation and solutions towards customers together always are more than welcome. Guys, basically, if you have any questions, really technical, I see that you have a lot of information for Pluto. Maybe you are not familiar with it, or with the Sentry, or whatsoever with safety. Really, you can contact us, me or Robbie, and we will try to support you as far as we can. Okay? This is the first thing. And the second thing, please use the really added values of Pluto, which are really simple. It's really well recognized in the industry for it. And DIN link is really something unique from us, which customers really save time and installation time and cabling. Okay? If this resounds in you and you need more and more basically support to go to a customer and talk about it, please really reach out. Feel free. Okay? More than welcome to support you.
I think we are done then here, and I would like to thank also presenters, Xin, Manuel, and Robbie also for taking part, and thanks a lot for your attention in this meeting. Please catch up with us. Any questions, you have the contacts from Manuel and myself, and we'll support you with all the best in the best way in your countries, and looking forward for your feedback also. Thanks a lot.